Welcome back. Glad you're here to join me for Skills Measured 2, which is implement and manage storage. In this functional group, we'll explore the following topics. Subgroup 2.1, configure access to storage. Subgroup 2.2, manage data in Azure storage accounts. Subgroup 2.3, configure Azure files and Azure Blob storage. Let's get started with Azure Storage. Azure Storage is a platform that allows you to save Microsoft solutions for modern. Azure Storage is a service that you can use to store files, messages, tables, and other types of information in a durable, secure, scalable, managed, and accessible way. Azure Storage allows us to store disks and files for virtual machines, unstructured data, or structured data. Let's talk about these types. From your self-paced journey or your experience, you know that Azure Storage for Virtual Machines allows you to manage either HDDs, which is the lowest cost of disk type, or SSDs, solid state drives, backed by premium storage. We also understand that we should manage or think about the governance for how we manage our data. How is it classified within Azure Storage? What is the default encryption method for Azure Storage? That might be something that you want to know. And what type of performance and replication strategy should we manage or should we be thinking about for managing the data that is attached to our IaaS, infrastructure as a service, virtual machines? How would we like to manage block storage for that disk or disk type? Do we have any file shares that we'd like to mount to our virtual machine? How do we do that? How do we execute those steps would be important to know for the exam. Unstructured data would include blobs, binary large object files, or data lake storage. Blobs are highly scalable, REST-based cloud object stores, and data lake storage, such as Hadoop, would give you a way to manage file systems distributively as a service. Structured data will include tables, Cosmos DB, and Azure SQL database as an option. Tables are going to be your key value, your auto-scaling NoSQL stores, your Cosmos DB options, which are globally distributed database services, or is a globally distributed database service. So how do we get the best performance with that data? Um, we also should think about the fact that our structured data is going to be non-relational, and there are other options for relational data. Important to know. There'll be other options for relational data. Let's explore some of the primary data sources for Azure Storage. Azure Storage includes a platform of data services listed in this display. Azure Storage allows us to manage four types of data to include Azure Containers, which manage that highly scalable unstructured object store for binary data, blobs. Azure Files, which allow us to store and manage file shares for cloud or on-premises as directories. Azure Tables, allowing us to use NoSQL Store for a schemaless storage of structured data for entities, and Azure Queues, which give us the ability to manage reliable communications between applications. There are different approaches and strategies for managing all four of these. You may see a question that asks you if you can mount a blob. That is not true. We know that we can't mount a blob, but we can access the container that blobs live in. We may have a question that asks if there is a limit to the number of blobs that we can create. We understand that there isn't a limit to the number of blobs that we can create. So understanding these different types of storage entities or examples and how each one of these objects are managed in the hierarchy so that blobs live in containers, that directories are associated with files, entities with tables, and messaging with queues is very important for the exam. When accessing storage, remember every object that you store in Azure Storage has a unique URL. The storage name, the storage account name, forms the subdomain of that address, and the subdomain and the domain name forms an endpoint. The endpoint will correspond to the type of storage associated with it. We see in this example that we have containers, which has the unique storage name as well as the target endpoint type for that particular storage data. Also important to note, so you should know these four different types of endpoint names. You may see an example that asks you to correlate the endpoint name to the type of storage for, say, a fictitious organization. So if you see a name that mentions something other than what you see in these examples, you'll understand the correct answer would be one of these four. Also important to note that you can configure a custom domain name with your storage account. What does that process look like? Do you go out to a domain registrar and purchase a domain name? That would be an absolutely correct way to secure a custom domain. But you still have to step through all of the validation processes to ensure that that custom domain has a unique address or a unique value before we associate that with your Azure Storage or any other services. So, do you fully understand that process? What does that process look like for taking a custom domain and adding it to Azure? Um, in doing so, once you've validated that domain with a text or an MX record, we understand that we can map a C name to our target in this example where we see blobs.contoso.com. So definitely understand the process of managing custom domain names and how to configure that for Azure Storage. A SaaS token provides secure and delegated access to resources in your Azure Storage account. It provides access to clients without sharing their storage account keys, provides access to Azure resources in multiple storage accounts, and delegates secured access to resources in one of the storage account services. You have all of those options with the creation of a SaaS token. Understand some of the best practices surrounding creation of a SaaS or shared access signature token, like time expiration, time zone creation to make sure that you align some of the access or the access needed for users to the correct time zone. Limit the distribution of the SaaS token. You may have an exam question that asks you of the options for creating a SaaS token with read permissions, what is a best practice for creating some of those options to include managing the expiry to create a SaaS using HTTPS as opposed to HTTP, and generating a token that lasts just for the specific duration to exercise least privilege. So maybe that question will ask, how do you create a secure token for multiple storage accounts for with least privilege in mind? So that would be a great example of a potential question. Configuring stored access policies provides an additional layer or level of control over service level shared access signatures on the server side. There are two stages for configuring stored access policies. One would be to create and modify stored access policies by setting a maximum of 5 access policies on table, container, queue, or shared at any given time. Understand too that The change in the update of that shared access policy can take up to 30 seconds before becoming active. You also have options to revoke or modify a stored access policy. And in doing so, you're able to delete or rename it or modify its sign identifier or change the expiration date value for that exercise. Now let's understand storage security and authorization options. Now let's talk about some high-level security capabilities of Azure Storage. Azure Storage provides a comprehensive set of security capabilities that together enable developers to build secure applications to include Azure Active Directory, shared keys, anonymous access to containers and blobs, and shared access signatures. So, really important to understand the differences between these types to include Azure Active Directory as a cloud-based identity and access management option that gives you fine-grained control over resources. Um, Shared keys will allow authorization and relies on access keys and other parameters to produce encrypted signature strings and pass them along in the request header. Anonymous access is something that you may want to grant only for information or data that may not be deemed sensitive, such as personal information like addresses, SSIDs, etc. And finally, SAS or access signatures, shared access signatures, allow you to delegate access to a particular resource in your account for a specific amount of time. So over a specified time interval with specified permissions. Now let's explore how key vaults will help with that. Azure Storage encryption is enabled on all storage accounts by default, including both Resource Manager and Classic Storage accounts. When we configure Azure Storage, we have key benefits of applying storage service encryption on all new or existing storage accounts. It's there by default. So some of the key benefits you should remember are that SSE protects your data for security and compliance, is automatically applied using 256-bit AES encryption, and that you have options for managing those keys. You can have Microsoft manage those keys for you, or you can bring your own keys and perhaps store them in an Azure Key Vault. Azure Key Vaults in depth are not covered in the scope of the AZ 104, but it might be a great idea to understand that you can have Microsoft rotate your keys for you, or you can take on the process yourself using a key management system like Azure Key Vault as a platform as a service option. Let's begin discussion of what types of tools enable us to manage our storage account. From your study, you learned that there are different kinds of storage account configuration tools, and Azure Storage allows us to use either Azure Storage Explorer, Azure Import Export Services, or AZ Copy to take advantage of managing our data. Azure Storage Explorer gives us a way to view multiple storage accounts across multiple subscriptions in one view. So we're able to use Storage Explorer either in the portal or as a standalone browser option to view our blobs, our queues, our tables, data lake storage to obtain SAS keys. And this is available across multiple platforms, Windows, Mac, and Linux. Then we have Azure Import Export Services, which allow us to move data to Azure Blob storage or files, or maybe export service, use the export service to move data to Azure Blob storage only. Lastly, we have AZ Copy, which is a command line utility available on all platforms as well. And it's designed to allow us to copy to and from blob storage files and table storage, as well as to execute some authentication integration to include Active Directory or SAS tokens. Now let's talk about redundancy. This is a key portion of the storage content. We should understand that there are some options for default redundancy in paired regions, as well as choosing how we'd like to replicate our data across regions. When deciding which redundancy option is best for your scenario, consider the trade offs between lower cost and higher availability. Azure Storage Redundancy gives us the ability to manage these factors and choose redundancy options, which include how our data is replicated in the primary region and whether it is replicated to a secondary region that is in the same geography or a different geography, whether we want to guard against zonal failure or just data center failure. So we do have options in the primary region to replicate using LRS or ZRS, zone redundant storage, or to a secondary region using geo-redundant storage or the read access version, or geo-zone redundant storage. When you create a storage account, you may have a question that asks on the exam, which of these options are the default for creating a storage account? What replication strategy would be the defaulted option? Speaking of object replication, let's explore how Azure Storage replicates objects to another region. Object replication happens asynchronously, where copies of, say, for example, a blob between two storage accounts, a source and a destination, are managed or copied into a secondary region, rather. There may be some latency for read requests that you have to consider. Um, Maybe consider some of the use cases for managing cost optimization to another region. There may be other things to consider about that region that make costs prohibitive, as well as thinking about how to efficiently manage these workloads and distribute data for scenarios like backup recovery and disaster recovery, which are not totally in scope for this exam, but it is a great idea to think about how LRS applies to object replication, how ZRS applies to this object replication, and understand how this replication occurs. Replication strategies give you the following options. Each one of these, local redundant storage, for example, gives you data replication of 3 copies in a single region. Zonal redundant or zone redundant storage, ZRS, 3 copies, 2 to 3 facilities, either within a single region or across 2 regions. Geo-redundant storage, we know, gives us 3 copies in the primary region and 3 times or 3 copies in the regional pair. For the exam, you may see a question that asks you if you can choose your regional pair. We know that we can. That is a part of the default values embedded in Azure. When you choose one region, it automatically assigns a regional pair. But we do have choices for how many copies into that pair we are creating. Another option to explore and note for the exam would be read-only geo-redundant storage, where we copy a primary region with 3 instances of that data, and we have an asynchronous copy read to the secondary region or a copy to the secondary region for read access only. We have the same options, but with zone redundancy, where we are spreading the initial 3 copies across availability zones and another 3 copies to the regional pair. And we have the same option as above with read access. So while this may be a little bit confusing, I'm sure we've all done our study. And one of the key takeaways is understanding uh, availability zones, fault domains versus update domains, and how that separation of the two work before you sit for exam. Now let's segue into files versus blobs, another storage type. Once we've decided the replication strategy for our storage account, we know that we have to populate it. We have to choose the type of storage that we want to live within each of those accounts. The following compares how blobs and files work. We know Azure Files allow an SMB interface for interacting with our directory structure. Great for lift and shift applications. So know some of the scenarios that would enable or empower an organization or user to manage Azure Files versus Azure Blobs. Unstructured, flat namespace, great for massive scale of block blobs. Um, Also wonderful for support of streaming and random access scenarios, as well as application access or data access rather from anywhere in the world. So one of the key components that we know to be true of both of these data types is access from anywhere in the world. So sure, we can access Azure Files or Azure Blobs, but there are some differences between the structured version Azure Blobs, or unstructured version rather, and the directory or hierarchical um, nature of Azure Files. Know the difference. That would be wonderful. When you're creating an Azure file share, you may see a portion of the exam that hypothetically asks you about the steps needed to manage a file share. Um, one of those, some of those steps include figuring out the configuration or understanding the configuration for Azure Files for Windows or for another operating system. We know that Azure allows us to choose a drive letter to map our Azure file for Windows and gives us a bit of default PowerShell that allows us to check in for a specific port. So it may be a great idea to understand what this process is like and what happens, say, if this port were closed. What could potentially prevent an Azure file share from connecting over port 445? And how would you troubleshoot that? Also, thinking about the default type of encryption associated with managing Azure files, remembering that this Azure files data type is managed using an industry standard protocol, SMB 3.0, and has encryption as such. Azure Blob Storage is Microsoft's object storage solution for the cloud. Let's explore configuring a blob. In this example, we see the creation of the container where we would upload or download block blobs. There are several types of blobs to include page or block, and it's important to understand the differences between page blobs. You may see an example on the exam that mentions how to store a disk connected to an IaaS virtual machine workload. We know that to be a page blob versus a block blob. So please understand that there are several types of blobs besides block. And this is just one way to upload or download or access that type of data. When configuring storage tiers, we want to think about how frequently or infrequently we need to access that storage tier. Accessing your data would align with the choice of an access tier. And Azure Storage offers different access tiers so that you can store your blob data in the most cost-effective manner based on how it's being used. So for our blob storage, we have the ability to access or configure three different tiers, and each one of those tiers has different features. The hot tier is wonderful for frequently accessed data, cool for less frequently accessed data. Uh, with an average of 30 days minimum retention period. And then the archive tier would be the least frequently accessed or rarest access data tier with upward of 180 days of minimum retention period. So you may have a question again that asks you to drag and drop which of these values are associated with which tier. That would be a wonderful exam question to prep for. Um, and which latency, which one has the highest latency? We know that to be the archive tier because of the hours of retrieval required to access or recover or rehydrate that tier of data. There are some automation rules that you can access or take advantage of to include storage lifecycle management, which offers rule-based policies that you can transition or use to transition blob storage or blob data to the appropriate access tiers, or to expire the data at the end of its life cycle. With optional lifecycle management from our study, we know that we have options to create if-then blocks where we can choose the last modified date and create a responsive action based on our choices or our rules that we add to this lifecycle management creation. Let's test our knowledge. Question 1. What is the order of operations to rotate storage account access keys? So here would be another sequential order question. This question would require you as a exam taker to order or reorder the options here with the correct sequence. Regenerate secondary access keys, regenerate primary access key, update connection string with secondary access key, update connection string with primary access key. Let's see the correct order. So here is the correct order. We would first want to update the connection string with a secondary access key. 2, regenerate primary access key. 3, update connection string with primary access key. And 4, regenerate secondary access keys. So if this example wasn't familiar, then I would suggest checking out Microsoft Docs to understand how key rotation for storage access keys work. Question number 2. You use a Microsoft Storage account for storing large numbers of video and audio files. You create containers to store each type of file and want to limit access to those files for specific periods. Additionally, the files can only be accessed through shared access signatures. You need the ability to revoke access to the files and to change the period for which users can access the files. What should you do in order to accomplish this in the most simple and effective way? 1. Create a SAS for each user and delete the SAS when you want to prevent access. 2. Use Azure Rights Management Services, RMS, to control access to each file. 3. Implement stored access policies for each container to enable revocation of access or change of duration. Or 4. Periodically regenerate the account key to access files to control access to the files. The correct answer is 3. We would implement stored access policies for each container to enable revocation of access or change of duration to manage the ability to revoke access to files for a specific period for certain users. Let's review what we've learned in Skills Measured 2. In this functional group, we've covered the following key points. We talked about Azure Storage, giving an overview of services as well as accessing storage, generating SaaS tokens, configuration of policy and authorization options, discussion on configuration of storage encryption and some of those key benefits, talking about storage configuration tools, redundancy, object replication, mapping and managing file shares, files versus blobs, some of the configuration options for Azure Blob storage, as well as storage tiers. And finally, discussions around Blob lifecycle management and rules. This concludes Skills Measured Area 2, all about implementing and managing storage. I invite you to join me back for Functional Group 3, where we discuss deploying and managing Azure Compute resources.